Welcome to EDU World Space.
Problem 768, you are designing an amusement park ride. We have a cart with two riders that moves horizontally with speed v equals 6 meters per second. We know the mass of the cart. The cart hits a spring and it's attached to a wall, and the cart comes to rest as the spring is compressed. So it moves here, it slows down, and it regains speed as it moves back in the opposite direction. Okay, so for this ride to be thrilling, maximum acceleration of this cart during this motion should be 3g, and we're ignoring friction. So we're asked what's required force constant in the spring, and then we'll get to B. Okay, so first off, what we need to do is we need to figure out what's the maximum compression of the spring, how that relates to the acceleration. So what we can do is we can write our sum of forces that is equal to the mass times acceleration of the cart. So then we notice that the only force that is going to be acting on this cart when it's compressed is going to be the spring force, the elastic force due to the spring. So we can write that down. We have Kx is equal to ma. And here we can substitute in what our mass and our acceleration is. I'm just going to leave mass as m, 3g. That's what our acceleration should be at this point of maximum compression of the spring. So then we can find what k is in terms of x. Okay, so we need to find x first, apparently, in order to get our spring constant. So let's go on to B. So what's maximum distance the spring will be compressed? Okay, so what we can do is we can write down our sum of forces, our conservation of energy equation. We notice that in the beginning here, we only have kinetic energy, and at the second point, we only have elastic potential energy. So we can write those down. We have 1/2 times mass times velocity squared is equal to 1/2 k x squared. Okay, and we can then substitute in what we know for k. We have 1/2 mv squared equal to 1/2 m3g over x times x squared. And then we can cancel out one factor of x, one factor of m, and the 1/2. And what we're left with is v squared is equal to 3gx. Okay, then what we can do is we can solve for x, sorry. So we have x is equal to v squared over 3g. So that's going to be 36 over 3g equals 12 over g. So 12 divided by 9.8 is a number. So if I plug that into my calculator real quick, I get 1.22. So that is B, the maximum distance the spring will be compressed. That's part B. And then if we plug that in up here, we would get K equals 300 kilograms times 3 times 9.81 meters per second squared divided by our 1.22. And if I plug that into my calculator real quick, I get 300 times 3 times 9.81 divided by 1.22. I get 7, 2, 36.9. and it's going to be newtons per meter. And that's our solution.